Hello, my name is Zach Payne, and I am doing Yersinia pestis for my research project, and this is the microbe that has caused the Black Death and multiple other pandemics of the plague in history. So, to start off with some background and history of that, it was Yersinia pestis was discovered by Alexandria Yersin in 1894. It is a descendant of Yersinia pseudotuberculosis, which has been carried and passed on for millennia, and it has also survived the Neolithic and Bronze migrations, which were very large migrations of human populations in a given time period, and there is a little bit of issue with this. The running theory per se of the migrations in Yersinia pseudotuberculosis is that we can't find any other microbe that it might have come from, and that comes into question: what did this develop from in the first place? And we aren't able to prove that just yet, but this is what they have found so far. Some more history. The three recorded outbreaks, the major ones that were recorded of Yersinia pestis, however, is the plague of Justinian in the 6th century, the Black Death from 1347 to 1353, and the third pandemic from 1855 to 1959. And as we can see here, the spread of each of the diseases. Up here for the Black Death, this is by Bulgaria. So it really came from Sarai and that region, and then kind of swept west, and that's how it killed over 25 million people in the span of less than a decade. This other portion over here, the third pandemic took place in China, and this region is the Yunnan region, and from all that I have gathered, I believe that they had a few cases outside of the Yunnan region, but it was mainly concentrated there instead. Each outbreak, though, has had a different biovariant or biovar, and as you can see here, I'll just go through the list. The Justinian plague was the Antigua biovariant, the Black Death had the Medievalis, and the third pandemic had the Orientalis. All of these have different markers that identify them as such, and I was not able to understand the complex naming of these biovariants, but there were also pestoids, which were different strains of the disease that did not progress as much as others did, and it did not spread near as bad or kill near as many people as these three outbreaks have. Some epidemiology. Yersinia pestis is gram-negative, non-motile. It is a coccobacillus, and it is non-spore forming. It is also a facultative anaerobe and is considered a sylvatic disease, which is a disease transferred from rats to humans. And as you can see here, this is what Yersinia pestis would look like underneath a microscope. As we can see that from the pink and the safranin dye that it has, that it is gram-negative. And some of the bacilli are round. As you can see here, this one, it is kind of round. It's not really truly bacilli shaped, which gives it that it gives it a characteristic which we will see later. So the mode of transmission is also determinant on what are you infected with first. So the bubonic plague came from the rats, and the fleas bit them, jumped off a rat, jumped onto a human and said, "Hey, you're a tasty snack and I'm going to bite on you." And that's how they got the bubonic plague. And that's where it takes over your lymph nodes first and causes buboes. Secondly is pneumonically from human to human by direct air contact. That could also be with an animal though. If the animal or human per se has the pneumonic strain of the disease, and they could breathe on you or maybe somehow indirectly contract air droplets or germs from someone, then you'll end up with the pneumonic strain. And then the septicemic strain comes from consumption of the disease, and that was generally from animal meat that caused this in history. Just because animals would get infected because fleas would bite those animals too, like cows and pigs and sheep and animals of the like, which, I mean, people had to eat meat in order to survive. And so, without knowing it, they contracted septicemic Yersinia pestis. A little bit more epidemiology. Here are some symptoms. For bubonic plague, you'll have the initial bite and infection of at least one bubo, which is a swollen lymph node, infected lymph node with Yersinia pestis. Is developed within 24 hours. If bacterial transmission to the bloodstream occurs as a complication, septicemia will be induced, which is poisoning of the blood. And that really comes from if a bubo ruptures and other vessels around it rupture, then it can infect that way. The septicemic strain, whenever you're first infected with it from consumption, it will rapidly infect your immune system. It'll then shut it down and induce septic shock, which will overflow your circulatory system and kind of just build up. It's a mass log phase of bacterial growth that takes place, and it just concentrates in the circulatory system, which is deadly, and you will die from multiple organ failure as a result. The pneumonic version of this strain, it also can occur as a complication of the bubonic or septicemic versions. Someone who is infected, however, will experience fever, chills, rapid heartbeat, difficulty breathing, cough, chest pain, severe headaches, and the coughing up of bloody sputum. And the individual usually dies from respiratory distress syndrome. And all of these can occur within 24 hours, making it a very, very, very deadly and dangerous disease. I just wanted to show this picture, going back to the shape that the bacilli are for Y. pestis. This individual's forearm is swelling in a kind of circular shape, even though it might be circular with any kind of infiltration like that. It's seen as a kind of bulb, just as the bacilli are, which is interesting. But we can also see the necrosis of all these infected places on this individual's body, and that's part of the multiple organ failure, and how it's just the body is literally just dying on itself. Treatment for Yersinia pestis includes, but is not limited to, all of these antibiotics, streptomycin, and I believe doxycycline. They both lyse the plasma membranes of these. It's a very strong lyser, if I can put it that way. However, current research is finding that cysteine residue mutation is effective, and vaccines that have the LCRV antibodies protect best against the plague. And that is it. That's all I have. Thank you for coming to my TED Talk.